Hi everyone. Thank you very much for attending today's webinar. Today's topic is SQL-like data preparation tricks in RapidMiner. My name is YC Lee. I'm an AI project consultant with Scientific Formosa here in Taiwan. I have been a consultant for the last 10 years. Before that, I have worked or taught first in US and then in Taiwan for more than 20 years. So this is a sequel, but anyway, sooner or later, people who are interested in using RapidMiner will run into SQL. This is a database language called structural query language. It is ubiquitous. However, as popular as it has been, it is rather hard to deal with that with proper IT background. 2 years ago, in a RapidMiner workshop we held for ICU professionals, we were asked to refer to Mimic 3, a medical database for all the training material. This database is useful and provides in GitHub many SQL scripts that implement some important concepts in medicine. And shown here is the Angus criteria for sepsis. It looks up into the ICDs, the International Classification of Diseases, for infection groups, for diagnosis performed, or the mechanical vent used, etc. While the participants of the workshop seems to be able to read such SQL scripts after a short tutorial, they were still very hesitant to write a new one from scratch or modify an existing one. As such, even though RapidMiner allows users to embed SQL queries in a database operator, the participant would like to see if they can build a logically equivalent RapidMiner process and modify it whenever needed. Here is a quick review into this SQL statements, and let's see how they can get complicated quickly. Okay, first, it's use alias to include the same relation more than once. As you know, sometimes we have self-join, etc. Right? Now we can start calling the attribute name in a simple name, so easier to code here, and that involves also various kinds of joins and some partial matches of the attribute values. Now, then we can group records into subsets, qualify the subgroup with some criteria and order them, and then generate some aggregations for each subgroup. Finally, it might be able to derive additional attributes. For example, here, we like to set 2 thresholds for a particular attribute value. If it's higher, it is good. Higher than a higher threshold, it's good. And if that's below the lower threshold, is bad. And something in between, we call it fair. Syntax-wise, it's look a little bit complicated, but still, they are just logical statements that we can communicate well with. But we do know that what is difficult is the devils behind this logic, as it can easily get to miss some record or introduce some unnecessary or wrong records if you have write some of the SQL statement before. Okay, so you may ask, why don't we just realize them in RapidMiner, where we may be able to code easier and debug easier, right? By using these operators and checking on the intermediate results. It might be easier to read as well. At least it is graphically and better documented. Okay, so by and large, we can find corresponding RapidMiner operators that match the SQL statement individually or collectively. Okay, but we want to realize the concept in RapidMiner that someone else may have described it by SQL statement or in some similar high-level descriptions, right? So both SQL syntax and RapidMiner operators take time to learn, but they are not real challenges at the end, right? So what is important is that we like to grasp the essence, the essential concepts surrounding database transformations, so that we can properly formulate a problem, build a model, and operationalize it. And so the objectives here, as we have consistently in this series of tutorials, is that we want to build up our capabilities to build end-to-end RapidMiner process flow that are transparent and easy to maintain. Okay. So let me first provide some background information for the whole series of tutorials that we have compiled. And this webinar is the third tutorial. Okay. We have prepared these 6 tutorials mostly from different data prep perspectives. And we compiled end-to-end scenarios to demonstrate the pre-processing techniques. But why do we do that? What are the motivations and objectives, right? RapidMiner is powerful and easy to use, but still we continue to see some of our customers struggle to master the platform. And one of the key reasons, as we came to realize, is a lack of creativity or the instinct that blocks the users from problem formulation and solutions. Right? And oftentimes we do not have any idea about what attributes we can and should have in order to formulate the problems for training purposes. But by problem definition or formulation in this context, we mean that there are clear problem statements that also include what attributes should have been ready before training the model. Okay. So in order to leverage RapidMiner platform, our objectives here are to highlight those concepts and techniques associated with the data set transformation. Such knowledge will come in handy as that will increase the space of your imagination, right? So when we are presented with high-level and mostly vague business problems, we know enough about the possible variations so that help us to come up with different alternatives for the problem formulation and the formats that are required for the model training and tuning. So, but there are some prerequisites for these tutorials, right? And even though we list them in order, you can take these tutorials in any order you like. But we need to be familiar with the usage of this tool itself first. It is okay that the number we know we're familiar with is still limited, but we should be fairly familiar or feel comfortable about all these things as we pointed out by these red circles, right? We need to, for example, monitor the uses of memory, and we also like to open up the log panel just for debugging purpose. So when you feel comfortable and confident enough to handle this particular platform, then we come to this tutorial, and that will be very helpful. Okay. Say we have some machine learning problems here, right? Problem 1 is to predict the mortality within 90 days, and then for each sepsis patient that inside this Mimic 3 database. And we immediately after 24 hours of ICU stay, what's the mortality in 90 days. And the second problem is like the length of stay in ICU, right? Again, we just like to do this prediction immediately after the first 24 hours of ICU stay. But by that, we mean we have the measurement or whatever treatment done in the first 24 hours. So that's the only records that we can use, correct? So there's some variation of this problem, like problem 1 can be restated as like among the patients who survived for at least 30 days post the ICU admission, what factors are associated with 1 year mortality, right? That can be a useful problem to deal with. And for the second problem, the variation might be how about we have a rolling predictions on a daily basis, right? The original problem is after the first day, and what is the prediction after the second day? Things like that. But among all of them, we have some data to start with, and we like to go through the process to identify all the attributes that might be useful. And some of them we know is good enough, will help us as the observations, the input variables, right? And something in blue will be why, like the target, the label we try to classify or try to predict. But we of course split it vertically, some of them for training purposes, some of the validating purpose. But you might be wondering why I have these Z columns. These Z columns are those attributes that should not have been in this training job. The reason being, sometimes we take the snapshot of our database and try to do a machine learning problem. But you know, the database keep up to date, right? But for whatever you try to predict, the learning, for example, here is to predict immediately after the first 24 hours. Any record or attributes that will be available after the first 24 hours, it's kind of peak into feature. So that's what we call the information leak in the machine learning model. So some of the beginners in data science courses, sometimes we will brag about how good their accuracy is. And a lot of time, they actually run into this information leak problem because they include some of the fact that is strongly correlated to the target prediction. Okay. This Mimic3 database is freely available to researchers worldwide, and it includes a diverse, very large population of ICU patients. It contains highly granular data, including lab results, vital signs, medications, and then more information such as demographics, vital sign measurement, laboratory test results, procedures, medications, caregiver notes, imaging report, and the mortality, right, including this post-hospital discharge. It supports a big range of analytic studies such as epidemiology, clinical decision rule improvement, and electronic tool development. The database is useful and provides in GitHub many SQL scripts that demonstrate some important concepts in medicine, right? Our focus here, as we have explained thus far, is to realize some of these concepts as RapidMiner process. So, and this is an example of this Angus criteria of sepsis. We could have just implement them as a RapidMiner process while we're reading the script and to understand it, or while you're reading the paper and catching those logic rule and try to implement this RapidMiner process by yourself along the way. Again, if you are familiar, right, the reasonable good users in RapidMiner, you can always just implement it and look at the intermediate result and immediately check whether you have interpreted some logic wrong and guess wrong output, either missing some records or introducing unnecessary wrong records, right? So a RapidMiner process, as we try to emphasize here, might be simpler to understand and implement than a logically equivalent SQL statements, right? Okay. Before we proceed, we should still make sure that RapidMiner does have operators that connect to the database and retrieve results from the database according to the SQL statement we put in this operator, right? As we show here, the connector operator connects to the local Postgres database with Mimic3 demo data. Okay, and then here is some of this connection information you have. And for RapidMiner, we probably use a set macro to allow the user to specify their specific credentials, right? When they are using this flow, right? So you don't just have a flow available everyone with your own password. So this way you can allow whatever user who will be using this flow can enter their own credential through this set macro operator. Now here comes the focus of this slide. That is the read database operator in RapidMiner. Just allow you to, for example, look at the tables, their attributes, this system catalog or something like that. And then you can just start entering the SQL query in this panel here as like an editor, right? So we could have just copy the whole SQL statement, plug in here and let it run. Supposedly it will come out correctly, but things are not happening that way usually. Most of research will have their own exploratory type of urge, and sometimes the SQL statement may have little mistakes, and then you have to do some editing to make it work. So this is a case, right? And so there are some more reasons here that you may not have been exposed to. What if the database cannot be queried directly? The database is for operational use, and some of the database admin are very strict in terms of that the users, the ad hoc users, like data scientists here, right? We will come in and try to explore and try to experiment with queries. Some of these queries cover a big range, and then some of them are written by, how do I say, the beginners of the SQL. So that can deteriorate or drag down the performance of operational database. So usually there are some limitation by the operational database admin. And or if it's actually preferable to use RapidMiner process for readability and then maintainability. And it's not to say if we do it in RapidMiner locally, then the performance will be bad because of all this heavy traffic in the network, right? RapidMiner does have an extension or a particular folder for you to easily modify all this database processings into so-called in-database processing. And so the easy transform will make this database logically is done by RapidMiner operations, but effectively that query has been compiled and run in the database itself. So at the end, the traffic over the network will be smaller. Okay, so for this particular tutorial, we have a repository like this, right? And we use this demo database for Mimic3, right? The whole Mimic database is much larger than this, maybe close to 50 gig. And also we need to pass a number of courses mandated by the hosting organization. Luckily for this much smaller, like 4 gig or so, the miniature of a Mimic3 demo database is provided to everyone for this purpose, right? So in this tutorial, we just look at 3 interesting queries, right? And the first one is simple select from where, and that will get us warmed up, right? And the second one is a non-trivial lookups. So we will be just using this Angus criteria. And then the last one will be some statistical group by aggregates. These can be complicated as well with all these conditional statements. As you know, sometimes we have some of the measurements that are missing. So what default value will be used. And then we also collect aggregates from so many different attributes, right? So you will see right away. Okay, so to start with, this is a simple select from where things. So we are looking into for each ICU state, we would like to show the length of the stay and the exact age is when the patients are admitted to an ICU, right? And or the before death, or before death by the record, meaning by the system, or by the Social Security organization, and the time to leave, they leave the ICU respectively. So the most information are in these two tables where, for example, patient, the key is the subject ID, right? And then the attributes are like a date of birth, date of death by the Social Security number, organization. And for the ICU states, the key will be subject ID and hospital administration ID and ICU state ID. They have attributes like when the patient is admitted, is in the ICU, and when it's out, and the length of the stay. By that meaning, length of stay is actually available, has been calculated, but that's just for practice purpose. Here we will try to calculate them here. So we should be looking at a result like what we shown here, and the SQL statement, if you can quickly read it, is like I would like to select the attributes I like from these two tables, and where, of course, to join the two tables, the subject should be the same person, right? But under that select segment, we have some of the SQL statement where we try to use all these dates and the difference between day and then to come out with the age. So it's a typical formula there, but you might be a bit overwhelmed by these keys like extract the epoch from or whatever time. So anyway, but we know what logically it tried to do, right? So in RapidMiner, we would have a process here. And if you look at it, give a moment, you know exactly what they are doing. Retrieve from these two patients, and we select what attribute might be involved. We join them. And we try to calculate the edge, right? And then we will select some attributes. But anyway, first, this generate attributes. We have to specify what attribute we try to generate and what kind of logic we will have them. So of course here you're dealing with the data manipulation functions in the RapidMiner. And RapidMiner, typically we have something like the difference between two dates, right? And then we can easily calculate the duration as well. In RapidMiner, that is always in a millisecond. So a day has the 864, right? And the 5 zeros, right? For a day. And then once we get the number of days, then we divide by the 365 and quarter, and that becomes the number of years. So this can be easily done, right? And then we have this process included in the repository. So now move on then. So we would try to put some more restriction or be more selective. So we like to include the adults, but but include adults only, but will exclude the surgeries, right? So the patient should be aged just larger than 16 and should not be admitted under all this surgery kind of code. So the query is like this, where base as then select. Okay, so the shaded part, the base, usually we can call it like a subquery, meaning we try to stepwise, we first calculate this particular subset and use as a temporary relation and to join the subsequent part of the SQL for joining or whatever to generate more information, right? So usually conceptually you're doing by two stage, right? So where the base is like this, select from the two relations and come up with some attributes. Then after that, we do more selection as we like here, like age criteria or this the mission reasons, right? But anyway, you can see that the base is following what we did previously. Somehow, we already have a RapidMiner process earlier. So here, what we would like to do is just add this criteria. And by now, you should know that in RapidMiner it's relatively easy. We just add a filter operator where we state this condition we like to filter from, right? So once we add this age criteria and the surface is not whatever surgery type or category, then we're done. So now we'll ask, will the transfer time matter, right? By transfer time, because in this query, we refer to the third table, that is surfaces. And for the surfaces, they have all these attributes and subject ID, admin ID, and a transfer time. This is key or not, depending on how people view it. But anyway, on this table, in addition to the surface, they also have the transfer time, meaning what the time they transfer from ICU to do these services. So we're suspecting that will this transfer time matter? Okay. So it does. Right here we show some example, right? Okay. If we look at the output by the previous process, the second query, right? And then we also print out the transfer time. We realize, for example, on the top here, the transfer time or the transferred event is actually not within the in time and out time or ICU state. So by that, we can tell that this particular service is actually done outside the particular ICU state, right? It may have done way before or way after the ICU stay. So here is something we say, if we are not careful about the logic and whatever, we can easily introduce superiors type of record that will affect our training job later, of course. So for this, we'll try to make sure service will not perform during ICU stay, right? If not, we throw them away. We'll make sure they are within the ICU stay. So we add additional condition, and that's why they add in this example in the SQL statement with something I highlighted with a red run, right? So for RapidMiner, of course, we take the existing flow and try to generate some indicators to say whether this particular service is within the ICU state or not, right? And the reason why we use generate attributes here, I have to kind of point it out, otherwise people get confused. Remember, we do have some of the filter operator, but unfortunately those filter operator is to perform on individual attributes right? And then you set the condition larger or smaller or equal to some particular value. But here, if we try to have something like in between or and or more complicated logic, then we try to use generate attributes to indicate the logical determination of this particular condition. And then later we can filter them based on this indicator. Okay, that should make sense if you look at this flow. Okay, so forget about the SQL statement, and we have the RapidMiner flow like this. Okay, and I think, of course, unless you add all these comments very detailed, otherwise people will still have to look at the process and open and understand a little bit, and then look at the parameters associated with each operator, so to understand the whole picture. But it is reasonable, right? So here we look at the output, and earlier we have those I colored them in pink or beige, right? And then for the new flow, we can see the revised result will now is free of those wrong records. So we do have this new set that doesn't include those 4 undesired records. Okay, now that's done with the first example. I think you get the idea of that. Usually when we talk logically, we can easily move from SQL to RapidMiner, okay, and something like that. But it's no problem. It's basically is that RapidMiner allow us to just look at what we have, and on the flow, on the process flow, we can easily insert something, and we can check back and forth for what all this intermediate results to see whether we did the right things, we interpret the logic correctly or not. Now, the second example is what we earlier showed, this Angus criteria, right? And Angus criteria, if you're interested, you can look into some of the references, right? Now, a caution of the word here. Here, this criteria in the practice here is actually just to create a cohort, the population of the object we are interested in, right? So it's not to predict whether a person has sepsis or not, and it's just to actually to go in the database to pour out all the sepsis patients as a cohort. Why I say that? Okay, just a simple fact that this criteria involve all this billing information. Why did I say so? Those ICDs, International Classification of Diseases, a lot of them is because we need that for billing purposes. So for all this billing purpose, this is a lot of the after fact type of things, right? And then we can say that we are to collect the cohort of sepsis patient, but we never use something that is after fact like ICD to predict whether a person will have the sepsis when they are admitted into ICU. Okay, so now we just look at how can we interpret this particular relatively complicated SQL. Okay, so the criteria conceptually is like this. They will look into some of this group, whether that's explicit sepsis or some of the infection or some of the organ dysfunction, or whether the mechanical vent has been used or not. Okay, so it started out, as I mentioned, looking into all this ICD code, right? And right now ICD-10, and that's why they are used in the MIMIC-4, the newer medical database now. But anyway, we'll stick to this ICD-9 here. And as you see, that the logic is definitely not a non-medical person can understand. But so that's why we respect whatever they have in the SQL, and we like to take this whole piece of logic and try to implement them correctly inside the RapidMiner, right? So first of all, this SQL, for completeness sake, it is like start with this ICD lookup and then look into some diagnosis group or the process group, and then lastly try to aggregate all the information together before we can do the final determination. Okay, so first of all, I will just stick to this high level and try to show you for each these critical concepts, sub-concepts, how can they do it, right? So the overall process would be looking like this, and we do have this process in the repository. If you did not follow everything clearly up to this point, you can just open up that process to look. But anyway, bear with me here. So on the high level, we have this retrieve some admissions, and then we have a big composite operation here to collect all the sepsis cohort. Then eventually we select the attribute we want and store it as a cohort, right? And then what I do here, I have some comparison, meaning there are other doctors in the workshop. They also use SQL directly to come up with the answer. So we just try to compare them. But anyway, this big sepsis cohort include some steps like this, and it looks a bit complicated now, but we can try to explain them as good as possible in the following slides. Okay, so now let's start, right? And at the high level, we are looking into some of the indicators. Of course, this indicator is what we would like to generate along the way. Hopefully, at the end, we can follow this particular logical statement to determine whether a patient has a sepsis or not, right? So, what we try to do, for example, I would like to mark the infection group, those patients, with a value 1. So, I retrieve the diagnosis table. The table has the ICD code here, and here it is still using this older code, the ICD-9. Right now, the newer Mimic database, Mimic 4, is using ICD-10. But for this tutorial, let's stick to what is available in the Mimic 3. Okay, so after that, I have 2 consecutive attributes. We like to create a new attribute, and then we map onto that, map the new attributes onto the value we like to designate with, right? So for example, I first create infection attributes, and I populate that with whatever ICD code they have for each record. Right, so for a record, if the ICD code is 982, then we just populate this new attribute with 982. After that, we start doing some map function. You may have used this particular operator somewhere else, but what it does is that you will assign a value to those with matched value, and you assign some default value for those that don't match. So here we are looking at this infection attributes, right? And then we will replace what? We will replace those records with all these ICD here. So definitely we need to enter this particular entry here with regular expressions that is slightly different than what is shown here. Of course, this is a SQL statement, so we'll show how to do it, right? And but what's important of this map function is that we like to replace those match record with 1.0 for this infection attributes, and the missing value for the non-matched records, right? So you can see that for this replace what we are doing, I already replaced that original query by these regular expressions, right? Basically, this is all and with some of these dummies as arbitrary things, right? So what you can do is that just be careful about, here is all the 3-digit code as specified there, and the 4-digit and the 5-digit, and be careful about this parenthesis, right? Because logically this, if you're a bit confused, you can look again, play with this help function. There you come out with the design panel where you can click for additional reminders. So if we can do that here, then that particular map function is done. Now we have for the new attributes describing whether the patient is infected or not, right? And then we can actually generate more function, map more function for other indicators. So for example, we earlier generate 3 new columns, and we already dealt with this infection. Right now we can deal with this the organ dysfunctions or the explicit sepsis. And of course on the top we probably have to deal with a different table, so let's show that later. So for this explicit sepsis, that just a small number of ICD code matching with that we should be able to handle. And then also for this organ dysfunction, and that's about 11 or so, the ICD code matching. So we just follow the same way to label these attributes. So we now have an indicator for explicit sepsis and then the organ dysfunction, right? As for the mechanical vent, whether that is used or not, here we just refer to different tables. So we have to generate that new attributes, mech vent, and then assign the mapping the values with these ICD code and designate with the label 1, otherwise it's a missing value. So once we can use the map functions to map those ICDs to the indicator value 1. So we have done with all these ICD matchings, and for the selected group we have labeled those records with a proper indicator that is 1. So, but knowing that a patient may have 1 in different indicators, like infection is 1, and organ dysfunction is also 1, and the explicit sepsis may be 1 or 0, whatever, right? So what we can do is just use some imagination to collectively make the final decision. But first of all, we need to collect other attributes that did not participate in this ICD matching work. So we just use a join to collect other attributes. And then comes to the aggregation part. What we did is to just count all the ones, right? So for example, you can, for the particular patient, we can count, but ignore the missing values, of course, right? Otherwise your count will be not correct. So when we have this count, the logic will be like that. Instead of the sepsis that conceptually equal to 1, here we just change it to if the count is larger than 1, right? Larger or equal to 1. So that should be complete for this particular case. Now let's take back a little bit and make some quick summary, right? The ICD lookup might be a bit overwhelming, but as long as we know that we do have these map operations that can help us to check whether the record matches the interested ICD. If they match, we give them a meaningful label. The case here is 1, right? Otherwise, we assign the record with the question mark. That's a missing value. So later when you compare final result with your colleague or with other literature, you find out somehow that your answer is not matching theirs. So at this point, you may also have some doubt and some suspicion about some of the operation you did. What you can do is, of course, to take advantage of RapidMiner and to look at some particular operator you are interested in and check their input data set and output data set. And RapidMiner does help you to quickly find out what might be the problem. So to make sure that you can eventually make this logic or equivalent, right? So now let's move to this third example that is associated with the vital signs, right? And this vital signs is that particularly in ICU, we have a lot of measurements. And from these measurements, they will extract a group of very important medical signs that indicate the status of the bodies, right? The body's vital functions, right? And a few months ago, I was with one of my elder relatives, and in the hospital, he just done with some operation, and the doctor says that ask the nurse to keep track of the IO in detail, right? And of course, I can easily guess what IO is, right? So it's how much liquid the patient has taken and how much urinations, the amount they have. So the nurse may be busy, so they may miss some of the things. For example, if they have to do it every 30 minutes or every hour. And they keep use a pencil to keep on the piece of a paper posted on the wall. And this can be also mistakes here, right? An extra zero or smear by the ink. But anyway, the logic here, as you can imagine, should be able to deal with all these possible human mistakes, missing values or unreasonable value that's out of range, right? Okay, so if you look at this query is trying to calculate the minimum heart rate, maximum heart rate, or minimum blood pressures, right? Different blood pressures, right? So they will of course look it into the measurement of heart rate and try to come up with a minimum, for example. But they can only take the minimum out of those meaningful measurements. So how can they do the meaningful measurements and how they label this vital ID as 1, 2, 3, 4, 5 here? As you can imagine, there will be some logic required. Okay, so this is where they label the vital ID, right? So if the particular item, okay, the measurement, right? The item is in 211 and 220045, and the value is not negative. The value is not higher than 300. That's meaningful for the heart rate. In that case, then I will say this vital ID is 1, right? But down there you can see that for the blood pressure, the systolic blood pressure, they will label the vital ID. If they have a meaningful measurement, then out of those item IDs, then it will label this vital ID as 2. Right. So that's why you have different vital ID associated with different measurements, and they also make sure that the value is in the meaningful range. So if you don't have the vital ID, those measurements can be ignored, right? So this is where they have. Now, this is how they try to say that, okay, this heart rate are associated with these 2 item IDs. And then this systolic or diastolic blood pressures are these IDs, and arterial pressure or whatever, right? So, At the end, they will try to group it by, but that is for the final layout. But what's important for us to catch are all these out of range things or missing values. So let's look at that. Right, we will look into ICU states and the chart events. That's what they consider for all those measurements, right? And then you have corresponding values, right? So as you can see from look at the green part, they always have the value and what kind of value that is, what exactly the number is, and then they will see that the unit of measurement, right? So that is also important information to interpret the particular number. Anyway, for the vital signs, this is regardless of sepsis, right? So what we do, you can look at this example in the repository. But anyway, here, as I mentioned, that we will collect all the first 3 days, and we of course will label the number of days the records are associated with. And filter the examples just to, here it is just to pick a particular date you're interested in or something like that. So important is this, we will do the item ID mapping, and then we'll do this vital signs. So let's show what we have here, right? The first 3 days, first of all, is to have some kind of this use some datetime functions to determine. Now we use that whether it's before the second date or before the third date. Now you can see the logic will do that job. And then for the item mapping function here is we'll try to categorize those items. So we will go through this a little bit later. And then for the vital signs here is where we try to see the value is meaningful, is in certain kind of range or whatever, right? Now, let's look at the first step here. We need to look into this item ID to see whether they are for blood pressure or for this heart rate. And so there is some mapping, but the lookup list here we have is much shorter than the previous one. So you can see this here. Now, first step, generate attributes. All the attributes we like to deal with. First, we populate them with the original item ID, right? So for example here, for the blood pressure, diastolic blood pressure, we just use this simple mapping rule here. So we look at the DIAS-BP and we add to the list, right? We just take the old value that is the item IDs. Oh, the one we look at, we'll replace them with a new value, for example, 9999. Okay. And then for this glucose, we can do the same thing. But know that we have to make sure that 9999 as a value, we try to stick it in as for temporary purpose, is a legitimate. It's not a legitimate item ID. Anyway, what we try to do this first, group them into, label them into the different types, is because for different measurements under different category, they have their rule specifying the unit of measurement, right? So we have to interpret them properly in our next step. For the next steps, that is to really populate this vital sign with the meaningful value, right? So we have the flow like this. First of all, we will have to generate some attributes. These attributes here, that is before we do any aggregation, right? Let's put the logic, the qualification logic in here. For heart rate, we would like to make sure they are within the range. If within the range, we use the value number. And otherwise, we label them as a missing numerical, right? So this missing numerical is a question mark we used earlier, but in specifying for general, the inside this operation, the missing numerical is the defined constant in RapidMiner. Okay, so once we kind of copy and paste all this down to this operator. What we are doing is exactly, I'm sorry, I jump a little bit, it is to interpret things like this, right? No aggregation yet. Then we can do the aggregation, right? Aggregation is where we put it in the attribute we like. For example, for heart rate, we like to calculate minimum, we like to calculate maximum, we also like to calculate average. But what to group then? We need to have ID to identify the group, right? So in addition to the patient ID for ICU state or the measurement ID or the hospital ID, whatever, we also add another indicator that is the first 3-day indicator. And that we shown earlier that we label them either 1 or 2 or 3. That will be useful later when we try to do the subsequent modeling or whatever prediction we may be interested in, right? So after this, we are very much done. But what we like to do as a very last step is that for those records that don't have any vital sign generated, right? Meaning for all these columns, they have null values. So we do have 21 measurement here. So if they have more than 21 or equal to 21 missing values, we will throw those records away, right? So what at the end, we have only meaning for patient with the vital signs, right? So we are very much done now. And just quickly, you see this, we play with this SQL statement to start with, right? And we implement them as a RapidMiner flows. And 3 examples we have used. Hopefully you get a hand about this now. So for machine learning problems, we may have something like this, but along the way, we are careful and try to make sure that we prepare the data correctly. We don't use those information leaking type of records. So anyway, be careful about this. So the takeaway is this, right? SQL statements and operators in RapidMiner, they are equivalent in some way, or at least collectively equivalent, meaning you can do things in both platforms, right? And then the agenda item is we just illustrate all these 3 examples. And what we have learned here is that copy, edit, and paste SQL shouldn't be as scary as when we start, right? And RapidMiner really makes the job easier. Conceptually, we are looking at whatever SQL queries, but we try to understand them. And along the way, we put the segment of this SQL statement inside the RapidMiner. So that's how we practice. But at the end, imagine that if you have a problem and somebody tell you some of this business logic, the logic might be described in a SQL statement or not, maybe in the high-level languages. But without the concept clear and that being practiced so often in RapidMiner, you are in a much better position to leverage the RapidMiner to implement all this logic and check the correctness along the way. Okay. So thank you very much for attending. And by the way, the scientific Formosa is a representative of RapidMiner in Taiwan since 2017. And they have provided all this technical support and professional services. And Scientific Formosa has been representing many powerful and popular software tools for 30 years or more than 30 years now. And it has helped many of the customers going through their digital transformation initiatives. So thank you very much and see you next time.